So what does the tool chain look like? Well, this is one of the trickier areas of the cell matrix. A lot of the work has been done basically ad hoc by hand in designing circuits. So how do you go about designing a circuit? The purely manual way, you get yourself a big sheet of paper and you draw your circuit out and you try to allocate it to a set of cells. So you get some graph paper or something with blocks on it. This is for a two-dimensional system. And you start laying out your circuit and you try to build individual cells into the pieces of your circuit. So your gates, your simple small scale circuits like multiplexers and so on, you assign cells to those. And you place them basically the way that you have your schematic diagram laid out. But you need to leave routing resources available. So you need to leave certain cells available to connect outputs to inputs by using cells to build pieces of wire. And that's where it gets a little tricky. Now for small systems, this isn't too bad to do by hand, but for anything terribly large scale, it gets pretty cumbersome very quickly. There are a number of tools available that support this work. There's the graphical layout editor, which lets you copy and paste cells into a blank matrix. And it has all kinds of features to allow you to do things like pick up a set of cells and move it somewhere else, rotate a set of cells, um, replicate a set of cells. And so for example, if you want to make a piece of wire that covers 20 cells, you can simply select those 20 cells and paste a single cell wire into that and it'll fill it out. So it does all the obvious cut and paste type operations. You can also overlap cells. So if you have wire carrying a signal from west to east and you want to also carry a signal from north to south, you can take a north-south wire and paste it on top of the west-east wire and they'll get combined. Their truth tables will get merged and you'll have a composite cell. So you can start doing some of this by hand and it's really not too bad a process, up to, let's say, thousands of cells. Beyond that, it starts to get cumbersome really quickly. There's some command line tools for defining basic libraries of cells that let you basically write truth tables and it will compile those and you can specify where they should be relative to each other. But again, that's largely a manual process and most of the work done to date has been manual. Now there has been some work done on some toolchain development. There was a thesis done at Utah State University back in the early 2000s on doing a place and route algorithm. There's some other tools related to place and route specifically geared towards a cell matrix with varying degrees of success on them. This is very much an ongoing effort and it's a good research area for people who are interested in farming off research projects. But basically it's an open problem at this point as to how do you do an automatic translation from a net list or something like a Verilog description of a circuit into cell matrix truth tables. Once you have an assignment of cells into different locations within the matrix, compiling those individual truth tables, that's automated, and turning those into a final binary circuit that the simulator will ingest, that's automated, and also creating a sequence of configuration instructions that will bootstrap a matrix to turn it into some particular implementation. That's for the most part automated. The possible wrinkle on there being circuits that are self-modifying sometimes need special treatment when you bootstrap them. But all of that stuff is turnkey at this point. The real challenge is how do you take something like a netlist and lay it out on a collection of cells. Very easy process to define manually, very cumbersome to actually do manually, and still an open problem for automated tools.